So, the derivative of a sum is the sum of the derivatives. The derivative of a difference is the difference of the derivatives, but the derivative of a product is not the product of the derivatives. It can't be. And I say that it can't be because we know that the derivative of 5 times x is 5. But the derivative of 5 times the derivative of x is 0 times 1, which is 0. So obviously this is not equal to this. The product rule is unintuitive. It's not something I think most of us would figure out independently. And for reasons that I do not know, the product rule is traditionally stated in terms of functions u and v. This is the only setting I see functions with these names. Again, I don't know what the history behind it is, but I do know that the derivative of u times v is the derivative of u times v plus u times the derivative of v. And this is the product rule. So, for example, let's take the derivative of x squared minus x plus 1 times the square root of x. We've got one function, the quadratic, times another function, the square root. And what the product rule says is we should take the derivative of this first function, the derivative of x squared minus x plus 1 is 2x minus 1. And we should multiply it by the other function. No derivative here. We're leaving the square root of x alone. 2x minus 1 times the square root of x. And then we reverse what we're taking the derivatives of. That is to say, we leave the quadratic x squared minus x plus 1 alone. We take the derivative of the square root of x, which is 1 over 2 times the square root of x. If that is not clear, remember that the square root is a power. It's x to the 1/2. So I'm using the power root to take the derivative of the square root of x and to get 1 over 2 the square root of x. And then once we found those, we add them together. So 2x minus 1 times the square root of x plus x squared minus x plus 1 times 1 over 2, the square root of x. And there's not a whole lot of simplification to be done here that I can see. I guess we could FOIL and get fractional powers. The reality is that the product rule generally just gives you messy looking functions. You start with a function that doesn't look so bad, and you take its derivative with the product rule, and now you have a function that's messier than what you started with. That's just a fact of life when we are doing calculus with products. And of course, products are a fact of life as well. Like let d of x be a demand function. Let d of x be the number of units sold if we charge X dollars. Then how much revenue do we generate? Well, revenue is the number of units you sell times the amount you sold them for. So the revenue function is X times the demand function. And the derivative of the revenue therefore comes from the product rule. You've got x times d of x. The derivative of x is 1 times d of x plus x times the derivative of the demand function. So even though it's a little messy, the product rule is just something you're going to have to grit your teeth and commit to memory. It's a pretty fundamental fact of calculus.